Analysis of multiple choice question exam quality by doing the item distractor analysis in both Excel and SPSS using Kelly's equation method for item discrimination as given in the formula here. Analysis of multiple choice question exam quality by performing item distractor analysis in Excel. A distractor is a wrong or incorrect answer in a multiple choice question. If a multiple choice question have 4 answer options, one of the answer options will be the correct answer and the rest will be the incorrect answer options, and they will be called distractors. The function of the distractor is to distract the student from selecting the correct answer and will attract them to select the wrong answer, i.e. the distractor. So the distractor can be effective, functional, or can be ineffective, non-functional, useless. And the way to evaluate the item distractor is to use the Kelly's equation method for item discrimination analysis. I have already produced several video clips describing the background, the concept, and the method of Kelly's equation with associated example or data. The Kelly's equation for item discrimination equals to upper group minus lower group divided by the 27% total. To perform item distractor analysis using Kelly's equation, the total scores achieved by each individual student will be calculated, and then the total score will be ranked or ordered from a higher to a lower value. And then the students will be divided into two groups, upper group and lower group. The upper group will represent the top 27% of total score, and the lower group will represent the lowest 27% of total scores. So with the Kelly's equation ID discrimination, the value will be ranging from -1 to 1. An item distractor that have a value of -1 is a functional and is an effective distractor, as it is attracting more of low performing student to select the wrong answer, i.e. to select the distractor. And if the value is equal to 0, then the distractor is useless, ineffective, and non-functional, as it cannot discriminate between the high performing and low performing students. So it does not discriminate or distinguish, and both high performing and low performing students are selecting this distractor in equal proportion. And if the value is greater than 0 up to +1, again this value indicates that the distractor is inefficient, ineffective, as it is attracting more of the high performing student to select this wrong option or wrong answer. So this distractor, if it has that value, then it has to be replaced or rephrased. Here in Excel, I had placed a data taken from an exam paper for 25 students. participating in answering an exam questions that consist of a multiple choice questions. There are 15 multiple choice questions labeled as Q1 up to Q15, and each multiple choice question have 4 possible answer options labeled as A, B, C, D. For the correct answer options in each question, a value of 1 is inserted to represent that the student had answered the question correctly. For example, in question number 1, the correct answer is option P. For question number 3, the correct answer is option number A. For question number 6, the correct answer is option C. And for question number 1, as I have said that option B is the correct answer, then option A and C and D are the incorrect answers. Thus, they are the distractor that distract the student from selecting the correct answer. And in this data, the distractor had been given a 0 value if it is have been selected by student. For question number 1, student number 2 had selected option D, and student number 4 had selected option A, and student number 6 had selected distractor C. To evaluate the effectiveness of these distractor in distracting the student from selecting the correct answer and attracting them to select the wrong answer, then we need to do an item discrimination analysis using the Kelly's equation method. The way to do that is first to calculate the total score achieved by each participant, and this can be done by adding up all the correct answer for each individual student. So in this cell here, I'm going to type total score and then in the cell below I'm going to use the symbol of sum, and then I'm going to select the range of the data to collect the sum for all the 15 questions for the first student. And if I select and click enter, a value is generated of 14. That means the first student had scored 14 questions correctly out of 15 questions. And to auto-fill and auto-calculate the value for the total score or scores for the rest of the student, just select the cell, hold, click, drag and hold to the last student. The Excel will auto-calculate and auto-fill the value for each total score. Now, each student has his total score or performance for this exam, and as we can see here, some of the students had scored 10, some of them 9, and some of them 13, and so on. The next step is to rank these total scores from high to low value, and the way to do that is first to select the row for students, and in addition to the total score, and they'll scroll down until you reach the student number 25. So we have selected all the students with their multiple choice options they have scored. And to rank these data using the total score, select and click on the sort and filter and use the custom sort. In the custom sort window for the column, I'm going to select sorting by the total score, and in the order I'm going for larger to the smallest. And if I click on OK, again the software will rank the total score from the highest to the lowest. As we can see here, the higher scorer is 14 out of 15 questions, and the lowest score is 5. Now the next step is to group those 25 students to upper 27% group, upper group, and to lower group of 27% scorer of the total score. So we're going to, since we have 25 students, then 27% of those students will be close to 7. So we're going to select the top data for the top 7 scorer and the data for the lowest 7 scorer. And the way to do that is to type here upper group, and to count the scores in each group, going to next to the upper group cell, type insert equal sign, and then type count, select the count function, and then select the first 7 scores or data for the first 7 students. And if you click on enter, a value is generated. And to auto calculate and auto fill the value for each upper group for each item, select, hold, drag towards the last answer option. The software will auto calculate and auto fill the value for the upper group. And to calculate the value for the lower group, again we're going to type here lower group, and then next to it I'm going to insert the equal sign, and then count, type count and select the first count, and then I'm going to select the last or the lowest group 7 student scores for the lower group. And if I click on enter, again as we can see here, for these 7 with only 2 scores in it, 2 students had selected the wrong option, option A, in this group. And to auto calculate and auto fill the value for the rest of the answer options, hold, drag, and until you reach the end of the data up to here, and the value is generated. Now the next step is to determine the item discrimination, and the way to do that is to insert the equal sign and then open a 2 bracket, and in the between the 2 bracket we're going to subtract the lower group from the upper group. And the way to do that is select the upper group and then add the minus sign, select the lower group, and then after the bracket divide that by 7, as we had selected 7 students for each group. And if you click on enter, a minus value is generated. To auto fill and auto calculate for the rest of the answer options, again hold, drag, and a value will be generated for the rest. Now here, this value of item discrimination will determine whether a distractor is functional, effective, or it is non-functional or not effective. If we look at question number 1, and we will only focus on distractor A, C, and D. In the first distractor A, we can see that it has a value of minus 0.14. This is a minus value. This indicates that this distractor is functional, is effective in distinguishing between high performing and low performing. As we can see from this, the low performing student are selecting this distractor or this wrong option, answer option, compared to the high performing student. So for option A or distractor A, it is functional, it is good. For distractor C in question number 1, the value is 0. That means it is not distinguishing between high performing and low performing, which indicate that both group of the student have equal proportion of selecting this distractor. So it is ineffective in discriminating between high performing and low performing, and in this case it's ought to discard this distractor and replace it with another one that will attract more of the low performing student rather compared to high performing student. For option D in question 1, which is distractor D, again the value is minus 0.14, and that is a functional and an effective distractor. If we look at further options here, we can see for question number 2, the value is minus 0.28. That is a functional distractor. For question number 3, option or distractor B, again we can see here that the value is 0.28. Here in this case, I will call this distractor as non-functional or inefficient. Why? Because it has a positive value and it is attracting more of the high performing student to select this wrong answer options. So it is non-functional or it is not effective. So this distractor need or required, it is essential to replace this distractor or this answer option with either a rephrased distractor. So these need to be omitted or cancelled. And this is also the same for the rest of the values. Most of the values here, this is 0, so this is ineffective, this is ineffective, this is this one. For question number 7, it is again ineffective as it is positive, and so on. So this is the way to evaluate and assess the distractor or distractors and to determine whether they are efficient or functional, and they are able to distinguish between high performing student and low performing student in a way that they attract more of the low performing student to select the wrong option or answer option. This method of assessing and evaluating the distractor is based on the Kelly's equation method, and this will give an educator or an instructor a value to measure and then to assess and evaluate the distractor and determine whether a distractor is functioning or not functioning, whether it's need replacing or whether it's doing its job in a good manner in that it is distracting. So this is the way to do it in Excel using the Kelly's equation method. Analysis of multiple choice question exam quality by performing item distractor analysis in SPSS. A distractor in a multiple choice question is the incorrect or wrong answer option. A multiple choice question that have 4 possible answer options will have one of the answer option as a correct answer and the rest will be incorrect answer options, and those are called distractors. The function of the distractor is to distract the student from selecting the correct answers and attracting them to select the incorrect answers options or answer options. A distractor can be functional and effective if it is attracting low performing student to select the wrong answer, and it will be non-functional or ineffective if it attracts high performing student to select those wrong answers, or if the distractor doesn't distinguish between high performing and low performing students, and thus both high performing and low performing students are selecting the distractor at an equal proportion. And the way to analyze the distractor is to use the Kelly's equation method for item discrimination as given below here, that is equal to upper group minus lower group divided by 27% total. For calculating the ID, first the total score achieved by each individual student participating in the exam will be calculated, and then this total score is arranged from high to low, and then 2 groups are generated, the upper group and the lower group. The upper group represent the top 27% of the total scores, and the lower group represent the lowest 27% of the total score. An item discrimination will generate a value ranging from -1 to 1. A distractor that have a value of close to -1 will indicate that the distractor is functional and is effective, as it is attracting more low performing student than high performing student. A distractor with a value of an ID equal to 0 indicates that the distractor is non-functional and it is ineffective, and the distractor ought to be replaced or rephrased. If the distractor value of an ID have a value of greater than 0 up to 1, then the distractor again is ineffective, as the distractor is attracting more of a high performing student to select this wrong answer. Here in SPSS data view, I had placed a data extracted from an exam paper answered by 25 students that were answering 15 multiple choice questions from question number 1 to question number 15, and each question has 4 possible answer options labeled as A, B, C, D, and the correct answer for questions are given a value of 1. For question number 1, the correct answer option is B, and the student that selected the option B is scored as a value of 1. the other answer options such as A and C and D are the wrong answers or answer options. Thus they are the distractors that distract the student from selecting the correct answer. And the value for this distractor is given a score of 0. If a student select any of the distractor, then it is given a 0 value. Student number 2 here for question number 1 has selected option D, and student number 4 selected distractor A, and student number 6 selected distractor C. And to evaluate the quality of the multiple choice question exam is to do an item distractor analysis using Kelly's methods. And the way to do that is first to calculate the total score achieved by the participant in the exam. And the way to do that is to click on transform and then select the count values within cases, and I'm going to generate a target variable calling it total score, and I'm going to use the variable here, select them all except the student 1, transfer them to the numeric variable, and then in numeric variable, and then in the define values I'm going to select the value of 1 and transfer that into the box value to count by pressing the add and then click on continue. The software here will count all the correct answer by counting all the value that have 1 for each individual student. And if we click on OK, a new variable is generated to the right hand side as shown here, and I'm going to click on a variable view, and I'm going to do view editing here by decreasing the decimal to 0 and decreasing the column width to 4 and place the value in the center. Again, as we can see here from the total score, that the highest score achieved is 14 out of 15. So 14 questions were correct out of 15, and the lowest score is given here 5. For each individual student, the total score is counted and calculated. The next step in the Kelly's method is to rank these total scores in a descending order from high to low. And the way to do that is to click on data and then scroll to sort cases, and then in the sort cases we are going to use the total score for sorting the data in a descending order. So in the sort order, going to use the descending. If I click on OK, the software will rearrange the data so that the highest score is organized from top to the bottom. So the highest is 14 and the lowest is 5. So now the total score has been ranked. The next step is to transpose these data, and to do transpose, click on data, scroll down to transpose, click on transpose. In the name variable, select student, and in the variable select by all the variable by clicking on Control A, and then click on the arrow. All the variable move to this box. If I click on OK, the software will rearrange the data that the students now are on the top here, and the questions are in rows or cases. And I'm going here to do few editings for all this data, transposed data. The first thing, and I'm going to rename the student number and replacing the K by S. The way to do that is to click on Control F for find and replace, and click on replace, and then type K and then the symbol, and then in the replace I'm going to put a capital S for student, and I'm going to click on replace all, so all the cases are renamed as S1 to S25. The next thing to do is I'm going to decrease the decimals into 0. So select, copy, and then Control V. And the column width, I'm going to reduce it into 4, make it 4 for all, and then copy, and then Control V. And for the align, I'm going to leave them all the value in the center of the cell. So I'm going to select, copy, and then Control V to make it center. So the data now are neat and tidy. And I'm going to get rid of the row for the totals, as it is not required here, by clicking on selecting and delete. The next step is now to generate a variable for the upper group and the lower group. Since we have here 25 students, then 27% of those are nearly equal to 7. So we are going to generate an upper group and lower group. Each group has scores for 7 students. So, and the way to do that is to click on transform, then count, and then I'm going to place here in the target variable upper group. And since these data are in order, or these variables are in order according to the total score, then for the upper group I'm going to select the top 7 variables or scores, 1, 2, 3, 4, 5, 6, 7, and drag it into the numeric variable. And then in the define, I'm going to change, select a value of a range from 0 to 1, and click on add, and then click on continue, and then click on OK. So a new variable is generated for the upper group. Just to do some editing. Next is to generate the lower group. Again, click on transform, count values with or within cases, reset this, and type again lower group. And since we already know these data are in order, I'm going to choose the bottom 7 variables, 1, 2, 3, 4, 5, 6, 7. Drag it and move it to the variables, and then in the define values or value, click on the range, insert a 0 and then insert 1, and then click on add and then click on continue, and then click on OK, and again another variable is generated on the right hand side here. Going to do again few editing here, reducing the decimal to 0, the width into 4, and the data in the center. Once we have calculated the upper group, the lower group, it's time to determine the item discrimination for each individual distractor in the exam. And the way to do that is to click on transform, then click on compute variables. In the compute variable, going to generate a target variable, call it item discrimination ID, and for ID we're going to generate a numeric expression by opening a bracket, selecting now the upper group, placing a minus sign, selecting the lower group, close the bracket, divide that by 7 as we have 7 students for each group, click on OK. Again a new variable is generated. Doing a few editing here, I'm going to increase the decimal into 3 and reduce this to 4 and make it center. Now here we have the item discrimination for each individual distractor, and for question number 1, which have A, B, C, D as an answer options, we already know that option B is the correct answer, so the distractor are A, C, and D. If we look at the first distractor, the value is minus. This distractor is functional and is effective as it has a minus sign, which indicates that the distractor is attracting low performing student to select the wrong answer compared to the high performing student. For distractor C, the value of the item discrimination is 0. This indicates that the distractor is non-functional, is not discriminating between high performing students and low performing students, so it is useless and it needs to be replaced or rephrased. And if we also look at another question, number 2 has a similar pattern, and I'm going to look at this value here for question number 3, option P, which is again a distractor. And as we can see here, the value for the item discrimination is in a plus, and it is 0.285. This distractor is ineffective and non-functional, as in it is positive, so it is attracting more of a high performing student to select this distractor or select the wrong answer. So this distractor need to be replaced, changed, or rephrased. So this is the way to evaluate the multiple choice question exam and to analyze the distractor using the Kelly's equation method and to determine a value, and from that value we will assess the and identify which distractor is functional, effective, and which is not.